Hey everyone, welcome to this video on edge computing concepts and applications. I am Mohammad Ibrahim, and today I'm going to walk you through how edge computing works, where it's used, and why it's becoming so important in our industry. Think of this as a complete guide that's informative but also easy to understand. So let's jump in. What is edge computing? Edge computing is a new and growing way of handling data instead of sending all information to a far data center. Edge computing lets devices process data where it's created. That means faster results, less strain on the internet, better privacy, and don't have to wait for a round trip of the cloud. For example, a smart security camera using edge computing can detect motion and raise an alert immediately without needing the cloud access. Compare this to a traditional cloud computing, which involves sending data to the cloud, then to a server, and then it formulates a response. Cloud is great for massive storage, powerful analytics, but it can also suffer from delays and bandwidth issues, especially in real time issues when there's a need for an immediate solution. So, in short, edge edge is equal to local and real time and secure. Cloud is equal to central, powerful but slow for instant tasks. Now, why do we need edge computing? We need edge computing because modern tech needs speed. Take autonomous vehicles, for example. They generate terabytes of data per hour and can't afford delay. A few milliseconds could mean the difference between stopping a crash on time. Like we can see this in Teslas. As you know, Teslas come with self-driving, and these self-driving cars need to be self-aware and instantly responsive. They need to have a response time of a human or faster than human at times to stop an oncoming crash or a toddler walks in front of the car. So we need that. Edge computing also comes in hand in healthcare, like real-time monitoring of patients can alert doctors. Doctors cannot always be around patients, so having these systems around patients helps them to realize when there's a threat to the patient, and they can always be there to help them. And in edge computing, there's also an issue of network congestion. Sending every bit of sensor data to the cloud is expensive and inefficient. Edge computing reduces that by handling things locally. On the screen, you can see this latency chart comparison. Cloud computing might take up 100 milliseconds, while edge computing brings it down to under 20 seconds. That's a huge difference we're talking about in real time decisions. Now, yes, let's understand what is edge architecture. Let me explain how edge computing is actually set up. At the bottom, we have edge devices like sensors, security cameras, or smartwatches. They collect raw data. Then the data goes to edge servers, which are small data centers located nearby, like in a hospital or a small factory. These layers are the first layer of processing. Then, finally, cloud integration happens. Once the necessary data is sent to the central servers for a long-term storage or more complex analysis. So it's like raw data at the edge, then it goes for quick decisions locally to the servers, then deeper analysis in the cloud. This is the kind of pipeline which makes the whole system more responsive and efficient. Now, key components. Okay, so key components in a edge computer. So let's break down into four different key parts. First is edge devices, second is edge servers, third is cloud integration, fourth is network layer. Now I'll tell you about edge devices. They are like the eyes and ears of the system. And by me, what do I mean when I say eyes and ears? They are like the sensors, cameras, and mobile devices. Now, edge servers. They are the small centers which process information from where it's created. Like I told you earlier, like a hospital or a small factory where the data centers are located. Then comes cloud integration. This cloud integration is like a CPU, like how we've learned in computers. It acts as a brain for long-term memory and learning. Then network layer. This is like the nervous system. It passes information between all the parts, and this is very vital because this keeps a constant flow of information without hindering the daily working and flow of the edge computer. Together, these make edge computing powerful and flexible. And now, applications of edge computing. Where all do we really need edge computing? Earlier I told you about it in brief, now I'll tell you about it more. So, where is edge computing actually used? First, let's come to autonomous vehicles. They use edge computing processing to navigate real-time processes without having to wait for cloud signals. Like I mentioned earlier, a toddler running in front of the vehicle, a car suddenly stopping in front of you, or anything like that could happen. And then comes healthcare. And here we can use it in devices like a heart rate monitor, a wearable alerts for doctors, or the smart watches which a lot of the people wear right now. The biggest example is for the Apple watches. These watches have been known to save people's life numerous times. Like if you have seen the news, you would have read that a person was gonna suffer a heart attack, but the watch alerted him by detecting irregular heartbeat rhythm. Okay, now let's go for smart cities. In smart cities, it is used in traffic lights to help in traffic congestion. There are a lot of times you have seen on the signals there it will be written VAC or next to a signal. That means it is being monitored by a live edge computing, where the edge computing calculates the amount of time needed for a lane to get a green signal for the traffic to move. It calculates according to the traffic there. It uses cameras for that. And then edge computing also comes in the manufacturing in the factories. They use this as a predictive maintenance. Machines analyze themselves and then report before failure. Okay, these aren't just ideas, they're happening now, and edge computing is behind it. So now let's come to edge versus cloud performance. Here you can see this chart. In terms of latency, edge wins hands down. You can see it's also better in speed and privacy, since local data doesn't travel. It also keeps all your data secure. But cloud still leads in scalability and heavy analytics because of their mass. Because they are large in scale, they can process a lot of data compared to edge. Edge gives us quickness and speed and privacy. Cloud gives us scalability and heavy analytics. So the takeaway from this: use edge computing for real-time and sensitive operations, and cloud for big and complex workloads. Okay. Challenges and limitations. Of course, edge computing has its own issues. Security. More devices means more possible points of attacks. Each sensor and node need to be secure. Hardware limitations. Not every device has a strong processing power. Scalability. Managing thousands of distributed edge nodes isn't very easy. Standardization. There isn't a global standard for edge systems yet. This makes integration hard. But researchers and tech companies are actively working on to solving these problems. So, what's the future scope of edge computing? It's only going to grow now, and fast. With 5G networks, data speeds and reliability will improve, making edge computing even more powerful. Then there's edge AI, where artificial intelligence is built right into edge devices. Imagine a drone that learns from its environment in real time without needing cloud support. You can also see market growth graph here. which shows how edge computing is projected to grow exponentially in the coming years, especially as Internet of Devices becomes more common. You can see that how the market value of this has increased. Earlier it was here, and now by 2026 it's predicted to reach this, and then it does not just stop there. By 2030 it's going to go even more. So in summary, let's wrap it up. Edge computing brings data processing closer to where it's generated. It reduces latency, saves bandwidth, and boosts privacy. It's critical for real-time smart applications like autonomous vehicles, healthcare, and smart cities. But yes, it's not a replacement for the cloud, but a partner to it. It handles the urgent local decisions while the cloud manages the big picture. So guys, thanks for watching. If it helped, drop a like, subscribe.